Okay, this video is going to go through the electrolysis of molten ionic compounds. If you want to go over the basics, there's a separate video on the channel where you can do the basics of electrolysis. It might be worth just refreshing yourself, get those key ideas in and then we'll go through this in terms of an example. So what we've got here is an ionic compound. Remember, ionic compounds have a lattice, the ions cannot move. And what we've done to break that lattice, to make it molten, is heat it up. So we've heated it up. That breaks the electrostatic attractions, therefore the ions are now free to move. So we have what we call the electrolyte. To help us understand how this is going to work, we need to link this to this key phrase here, which says that oxidation is loss, reduction is gaining. Remember, we shorten that to oil rig, and that explains in terms of electrons, if we lose electrons, then it's being oxidized. If something gains electrons, then it is being reduced. Just in terms of charge, let's link that to charge. So you can see this way, what we're doing here, if you start from 0, we're becoming more positively charged. How do you become positively charged? You lose electrons. So this way here is about loss of electrons. Therefore, loss of electrons is oxidation. So if we head in a situation where we become more positively charged, we're being oxidized. Opposite is true, start from 0, we're becoming more negative. How do you become negative? You gain negatively charged electrons. Therefore, gaining electrons is this way. So this way is all about gaining electrons. And what's happening here then is reduction. So if we can remember that key phrase, or rig, that's going to help us to really understand this. The other bit of help we have on the in the periodic table, I've drawn it out here for you. We have our group numbers across the top. We know those group numbers help us to identify the charge on the ion that forms. So if you were in group 1, you always form a +1 ion. Here we have a +2 ion, +3 ion. Over here, I'm not going to put a charge on this because it's not going to form a charged ion. But here we're going to go backwards, so it's going to become 3-. Group 6 is 2-. Group 7 is a -1 ion. And here I'm just going to put 0 because they don't form ions for us. Remember the key thing, all the metals, so everything on this side of the periodic table here, always form cations. Cations are positive ions. The non-metals form anions, negative ions. Again, that might help you if you get into that situation. How do we know this? We need to understand the basics of that. So if we take lithium as an example, lithium is in group 1. It's got 3 electrons, so it's 2, 1 is the electron arrangement. How is that going to become stable? That's going to become stable by losing this outer electron. So it wants to lose that electron. If it loses that electron, it's going to become Li2. Losing a negative electron means it becomes a positive ion. +1, it's in group 1, +1 ion. Let's pick a different one. Let's pick calcium. Calcium has 20 electrons, so it's 2, 8, 8, 2. Again, that's not a stable electron arrangement. So how does it become stable? It needs to lose those 2 electrons. Loses 2 electrons, so it forms calcium, which is going to be 2, 8, 8. That's now stable, full outer energy level. Because it's lost 2 electrons, it becomes a 2+ ion. And again, calcium's in group 2. We know it should form a 2+ ion. Let's give some examples of anions in the same way. So if we pick on oxygen, oxygen has 8 electrons, 2 6 is the arrangement. That's not stable. How's it going to become stable? Well, it needs to pick up 2 electrons here. It needs to gain 2 electrons. If it gains 2 electrons, it's going to become oxygen with 2, 8. This is now a stable arrangement. The fact it's gained 2 electrons, which are negatively charged, means it becomes a 2- ion, so it's an oxide ion. And this is in group 6, and it forms a 2- ion. So you can see how this all links together, and understanding that is going to really, really help you. Let's just do one more. So fluorine has 9 electrons, which is 2, 7. Again, that's not stable. How's it going to become stable? It's going to become stable by gaining an electron. So it's going to pick that electron up, and when it does that, it becomes electron arrangement 2, 8, a stable arrangement. It's now gained an electron, just 1, so it's a negative charge of 1, a fluoride ion. Okay, so that hopefully takes you through that a little bit. Just a little bit more to add to this. Let's just use an example. So if I just get an example on here for you, let's say that we're going to look at sodium chloride. It's molten, so it's going to put a liquid state there. We know this is going to form ions that are going to be Na plus, group 1, metal, positive ion, and chloride ion, Cl minus, group 7, non-metal, negative ion, -1 charge. So when they're in the electrolyte, and we've got our electrodes, so our two electrodes are our cathode and our anode. The cation, the sodium ion, is going to be attracted to the cathode, so the sodium ion heads here. When it gets here, we're trying to turn this into a material that has no charge. We're trying to turn this element with no charge. So how do we take something that's positive and get rid of its charge? We add a negative electron to it. So we gain a negative electron, that forms Na. The fact we've gained an electron means that gaining electrons is reduction. So at the cathode here, we have got reduction of the sodium taking place. At the anode, my anion goes there, so it's Cl minus. This anion gets there, and again we want to lose this charge, we want to get rid of the charge. So this is going to form chlorine, releasing the electron that's causing the charge to be there. Now we've got to remember, don't fall into the trap. Chlorine is diatomic, so it's got to be Cl2. Because I need 2 of those, I need 2 of those, and that's going to release 2 electrons. So in here, we've got chloride ions forming chlorine by losing 2 electrons. Losing electrons, loss of electrons is oxidation. So we have reduction and oxidation happening. Remember, when they happen together, we call that redox. So the two processes happen together. Great way to get good at this is just go and practice, go and try some different ones. Please go back to your notes, go through the ones in the notes, have a really good go at them, and get comfortable, confident with doing those, and you'll be fantastic with that practice.